So, super exciting live this week because first we're doing a new format, and second, I have a great guest with John Sundell. So, welcome, John.
Hey, thanks for having me. It's really great to be here.
Thank you for coming. So, as you can see from what is displayed on the screen, this new format is going to be a live coding session. We are going to talk about KeyPath and we're going to talk about function and how the two of them relate together. But before we begin, a little bit of an intro questions. Maybe John, can you tell us a little bit how your very popular Swift by Sundell website got started?
Yeah, absolutely. So I first actually started writing articles on Medium. So I started writing and posting and blogging before I even opened up my website, before I even had an idea to open up my website. And that was really cool because I had this idea that I wanted to share a new article every week. And this was in the beginning of 2017. I wanted to set like a challenge to myself to see how many weeks in a row could I write an article because I had just left my job at Spotify. I had just moved to Poland. I had just become a freelancer. Like there was a lot of new things for me. And I had this one day a week, which where I didn't have client work, I didn't have any assignments. So I felt, why don't I just take this one day, which was a Friday, and write a new article on this day and share some, ideas with the community and see where that goes. And in the beginning, no one was reading any of my articles. That like there it wasn't like an overnight success or anything like that. So it took a good while for things to kind of build up, but since I was doing it every week, it was kind of this consistent thing that the small amount of people that were following me back then, they could kind of see that every Friday there's a new article coming out. So that kind of started to become a little bit more of a thing, and people started sharing the articles. And eventually on Medium I got a little bit of that network effect, and more people discovered it through Medium and things like that. So it started growing. And after a little while, I realized that, you know what, maybe I actually want this to be on my own website, because even though I still think that can be a pretty good place to start. I mean, now I know that people have different opinions about Medium now that, we're a couple of
It
years
changed a
later.
little bit, yeah.
Yeah, yeah, for sure. But back then it was really good. And I was very happy that I started there, but I felt like I wanted my own website. I wanted honestly, the number one thing that made me go to my own website was so that I could have syntax highlighting, because on
Oh,
Medium there was
yes.
no syntax highlighting, and that always bothered me. And I wanted like really good syntax highlighting, which is funny because then I moved to Squarespace and I had this JavaScript based syntax highlighter, which I was very happy with at the time. But then eventually, when I moved to static site generation and I built my own website and my own publish static site generator and all of that, and moved to a new server, that was also a lot because of because of syntax highlighting, because I wanted to have my own custom Swift based syntax highlighter with my own theme. So I don't know, like maybe I will move to something else in the future because of syntax highlighting.
But I think it's really a great insight what you just said. Like every big, big successful project starts small, and the key is to be consistent and to really like start with the simple tools and build and make things evolve as you go.
Yeah, exactly. I think that's really important, because the thing is that if you just look at numbers, right? If you just look at, how many visitors am I getting, or how many like people are watching my YouTube video, or how many people are listening to my podcast, or whatever it is you're producing, or how many stars does my GitHub project have? Like that's another thing people very often measure. The thing is that in the beginning, especially if you're just getting started, those numbers are not going to be big. Like, I'm sorry, but they're not, right? Like they weren't for me, they weren't for you probably. They're not for anybody. Like you always start with an audience of zero. Like that's just how it is. So the number one thing I think is it's important to do something that you like, because if you like it, you will do it over and over again and consistently. And if you do it consistently, then eventually people will start showing up. If you just do it enough times, someone will notice. And then if more people notice and they share it and it's of good quality, then, it might lead somewhere. It might also not, but there's a lot of luck and chance and stuff like that involved as well, of course. So the only thing you can really control, I think, is your own work, and try to make something of really, really high quality. Don't worry about the numbers, because they're all going to be low in the beginning, and the only thing you can really control is your own output. Going to too long lengths just to kind of search for an audience, I found that that rarely pays off. What really pays off is producing high quality work.
It's true. And I think most of the time it's very hard to predict what kind of content is going to like work very well. It's often the one that you don't expect to work very well that do, and vice versa.
Yeah, exactly. Yeah, it's sometimes it can be really surprising.
Well, let's now get on this topic of doing this live coding. So before we start, so even though we have of course prepared a few things, the idea is that we are live, things are meant to be interacting. So any questions that you have about KeyPath function, how they relate together, please ask them in the chat, and John and I will try to answer it as best as we can. So to get started, maybe a good thing would be to just give an overview just of what KeyPath are, because even though they've been in Swift for something like 2 years, I think there's still a little bit of mystery behind them.
Yeah, I think so. And they can be sometimes a little bit of a hard concept to kind of wrap your head around if you haven't done the type of programming more leaning into some functional programming concepts and things like that before. And you know, keypaths are in general like I'm not going to say that they're unique to Swift, because I'm sure that other languages have implemented similar features, but they're not one of those common features that you will find in every single programming language. Like they're not like functions or strings or integers that you will find in almost literally every programming language ever made. They are a little bit more special features. So yeah, I think it's good to explain it. Do you want me to do that and write some code,
Yeah,
or how do you want to do this?
yeah, go ahead, John.
Okay, cool. So a key path is essentially generic over two parameters or two generic types. And the first type is what root type are you referring to? And the second one is the value of the key path itself. Or the type of the value of the key path itself. And a key path can essentially be used to refer to a property on a type. So if I define a type here, and I'm going to say this is my user, and the user has a name, for example, and maybe it has an is logged in Boolean as well, then I can use keypaths now to refer to these two properties. And the way I would do that is I would type backslash user dot name to refer to the name property, and backslash user dot is logged in to refer to the is logged in property. So these will, both of them will be keypaths. In fact, now if we run this code here, we can take a look at here in the right of the playground here, we can see the type. And we can see we have here two writable key paths. And like I mentioned, the first generic type is the root, like the type itself that we're referring to, which is in this case is user. And then the name key path refers to a string property. So it has the string generic type here. And the is logged in refers to bool, of course. And both of these two are writable key paths. And the reason they are that is because we can write new values to them, right? So they are vars. And now if we change name here to let instead, so it becomes a constant, and we run our playground again, we can see that now this first key path here has become a key path, not writable key path, because now we can only get a value from it. We cannot write a value to it. And there is one more kind of major type of key path, which is a reference writable key path. And that is when we have a class that we're referring to, which means that we can write to this property using reference semantics. So if I define a class here instead, we can just call this class, let's call it article, and maybe it has a title like this. And I'm going to give it a default value just so I don't have to implement an initializer here. And now if I say backslash article dot title and we run this again, we can see that now this is a reference writable key path, which points to the article type and then string as the value. So those are the three main kind of key path type that you will encounter and the differences between them. So we can then move on to how we can use them. But yeah, this is kind of how key paths work or what they are, kind of the basics.
Yeah, that's how Swift deal with them, and that's very important to understand. I really like a sentence in the documentation because even though it sounds a bit academic, I think it's still insightful. They say that a key path is an uninvoked reference to a property. And I think this idea of it's uninvoked and you're going to invoke it later, it's also very insightful to what a key path is.
Yeah, absolutely. I think that's a good way of describing it. And It's very useful because it lets you, like you alluded to there and the documentation alludes to, it lets you reference a property without having the instance, right? So when you define, like when you pass an object around and you reference like its property, you need to have that instance or that value, like the reference to it. But with KeyPaths, you can refer to a property without knowing what instance it will be applied to, and that lets you implement some really powerful stuff where you can like use it for things like predicates or filters or stuff like that, or just like dynamic ways to retrieve data from different objects. Like it's really useful in general when you're writing kind of more generic utilities or libraries or frameworks and these sorts of things. Like it gives you a lot of flexibility, but still retaining full type safety.
And maybe one last thing we can say is about the name KeyPath itself. I feel like, I don't know if you agree with it, but in Swift, I feel like they chose this name because there was already a similar concept in Objective-C, also called a KeyPath, but in other languages, the same concept is more called an optics or sometimes lenses also.
Yeah, exactly. So it's a very specific type of lens, like into one property, right? And yeah, I think that's a good comparison. And I think I agree. I think that's probably why they picked the name because yeah, there was some kind of a similar concept that maybe Apple developers were familiar from before, and also like the name makes sense. Like because it's not it can't just be to one single property, and I think that's important to point out as well. We can create key paths to nested properties also, which really turns it into a key path, right? So it's not just a key but a key path. And actually maybe we can demonstrate that here real
Yes.
quick. So for example, if I wanted to extend my user type with maybe a state property or a state struct. So I'm going to write an extension here on user and say this is my struct called state, and maybe state, maybe actually we move the is logged in to the state instead, and we can then add some other properties here. We can say, for example, sign up date or something like the state of the user.
Yeah.
And now we can add var state here instead, like that. And now if you want to refer to is logged in, so now we can see this is the kind of the type safety and the compile time checks here in place. Like we cannot refer to this key path if it doesn't exist. We get a compile error, which is great. But now we can update this to say state dot is logged in. So we can refer to a complete path using key paths, not just to a single property, which is also really powerful.
Yeah, and something also that we can see is that KeyPath, they are entirely type safe. You make a typo, you get a compiler error. You try to use a KeyPath that gives you a string with a Boolean variable, you get an error also.
Exactly. Yeah. So you have complete type safety. So I think when we did our podcast episode together a while back, Vincent, you pointed out that it's not so much dynamic programming. Like you can look at this and think of it as dynamic programming, and I sometimes use that term because I do think it's a more dynamic feature. But I also agree that saying that is completely dynamic programming is kind of misleading because it's not, right. We're not doing something like in JavaScript where you can like subscript into an object with any key and retrieve a value, and that's great in dynamic languages. That's what makes dynamic languages powerful in a different way. But Swift is not. Swift is a very static language, and so this is like a dynamic feature in a static language.
Yeah, and I think a great way to convince yourself that this is not a dynamic feature is to point out that actually you cannot really init a KeyPath. You can create it using the literal syntax that you've just shown us, but there is no init that you can call on a KeyPath publicly.
Exactly. Yeah, I think that's a very good point. You cannot initialize it. You cannot like store it to disk or decode it or encode it and so on. Like it's not meant for use cases like that. It's meant for ways to refer to properties in a more dynamic way, in a way like when it comes to your logic, but still completely static when it comes to your code.
Exactly. Everything is going to originate from a static place. We have a great question, so I'm going to display it. So the
Okay.
question is basically, can we also use KeyPath with protocols and not just structs and classes? And actually, I was just thinking that I've never tried it. I'm thinking that it should work, but I've never tried it.
All right, good question here. I am quite sure that it works, but we're live here, and we might
Let's
make
try
mistakes
it.
and say, hey, let's try it, right? So we are not sure until we can try it. So let's make our user conform to like a nameable protocol, right? Nameable or nameable. I'm gonna spell it like this, even if it's
Yeah,
wrong. And then I'm gonna
there is a
say this is
name.
a string. Yeah, there's a name property in my nameable, and it's a property that you can get, and then I can make user conform to nameable like this. And let's now see if I can refer to nameable.name. Yeah, it looks like I
Okay.
can. So yes, you can use it with protocols as well. And come to think of it more, like that makes a lot of sense because when you use this with things like Swift UI, which uses key paths, for example, to decide what the ID is in a for each view, that is done generically, like, right, using protocols. So it makes total sense that you can do it with protocols as well. But I agree, I haven't really done that much myself, more with generics. So it makes sense that it works for protocols too.
And you know what? I've been thinking about the next question is, what if we add an associated type with the protocol? Is it still going to work? Like, does it require the type to have an existential or not? Like, if nameable had some kind of associated type about to represent the name, for instance.
Yeah, so this I am fairly confident will not work
I,
because you
I
can
would
never
say so
refer
also.
to a protocol that has associated values or self requirements directly. You need to have a concrete type for that,
Yeah.
right? So you can only use it as a generic constraint. So let's try. Let's add an associated type here, which is going to be called name. And let's make it a return name here instead. And if we now compile
Do we
this
get the
again,
error?
you can see that we cannot use this because you can only use it as a generic constraint. So the same rules apply as referring to types in other contexts, that you can only refer to it if you know the concrete type, or
Yeah.
it's a protocol without generic requirements.
That makes a lot of sense. And there was one very good remark also, which is that combined assign method uses KeyPath. And that's one thing about KeyPath. When they were introduced, so Swift 4, I felt like they were kind of like a feature without a use case. Because they were in the
Mhm.
language, but the library was not using them, the frameworks were not using them, and then Swift UI came up, Combine came up, and they all make a heavy use of KeyPath, and finally that's it, they make sense in the language.
Yeah, and that's the thing because we have to remember, like the vast majority of Apple's frameworks are Objective C, right? They're written in Objective C, so they cannot use these features because they can only use things that are Objective C compatible, right? Even if they sometimes write maybe parts of the OS or something in Swift, or there are some Swift components to it, fundamentally it needs to work with Objective C. But Swift UI and Combine do not have those constraints because they're brand new frameworks. They're Swift only, and they can make use of these things. So we are definitely seeing like Apple's own tools now making a lot more heavy use of Swift features because they are written in Swift. And it has pros and cons, like everything. It's a trade-off. I think in general now going forward, um, getting like pretty good at Swift as a language is going to be more and more important for being an iOS developer. Which you can have opinions about that, like that, and I'm not sure actually how I feel about that myself. Like to some extent, you would like the programming language to just be a tool that you use to write your code, and now with these more like Swifty frameworks that are coming out from Apple, they are making use of some really advanced features, and sometimes you kind of need to know about them in order to perform certain tweaks and to implement certain patterns. So yeah, it's a trade-off, but it seems to be the way we're heading.
It seems to be that KeyPath are definitely part of what is a Swifty code, or what feels as a Swifty code. And
Yeah,
talking
I,
about
th- I think I think so.
And talking about very cool features of KeyPath, there is one that came up as part of Swift 5.1, 5.2, one of these releases, which is the fact that we can now use KeyPath with @dynamicMemberLookup. And I think
Yeah.
we really ought to show it, because if you've never seen it, it has a kind of magic feeling.
Yeah, all right, let's take a look. So, this is another one of those things that is probably the most useful if you're writing generic code. And specifically if you're writing some kind of library or something like that you're sharing, or maybe some kind of utility that you're sharing across your code base for different purposes. So, to illustrate, let's go down here now and create a item struct that we want to enable someone to represent this as an item, and then you can attach your own metadata to it. So let's say that we want also to have metadata, which is a generic type. And just to make this a little bit more interesting, let's also require this to be codable. and in turn make our item struct codable as well. So you can imagine this being some kind of like API item that can have some metadata attached to it. So it might have something like, it can have an ID, for example. It can have a title, and it might then have also this metadata, right? And the powerful thing about this pattern is that now we can say, for example, I want to have an item which has like album metadata, or an item with song metadata, or an item with article metadata. Whatever you're representing from your API, you can now use this same data type for all of it, which is really powerful because it lets you kind of enforce certain degree of consistency and share code. And you might write these things to your database. You can then have one single code path for that as well. So it's really useful. But now then, every time you need to access some kind of custom property, you will need to always do item.metadata.property, right? So if we define in an item here, we say, well, first let's define some metadata. So let's say here is some article metadata, and that's a codable. And it might have, for example, in here, like a description. So now if I want to get the description for my item, I can first create an item like this. So I can say item is, you can say item, it has an ID, and that's a UUID. It has a title, which is just title. And then we can say it has some article metadata here. And then the description here is like, hi, an article, like that.
Perfect.
And here, like that. And we can just make some little indentation here just to make the code pretty. That's important, right?
Indeed.
So
especially when we have like not a lot of room to display the code.
Yeah, for sure. And we want it to be easy to read for everybody watching. So here's our item type. And thanks to the wonder of type inference, we now know that this is an item. And it's funny here in the playground because you get this like underscore lib expression 14 dot article metadata. But we know that this is an item which is generic over article metadata. So we don't have to specify that ourselves. Type inference takes care of it for us. But now if I want to access my description, I have to say item.metadata.description. So I have to always go through this metadata step in order to get my description. And I mean, that's fine. It's not a huge deal. But what if we wanted to make this metadata feel more like a first class properties on this type? Could we make that happen? Like, of course, one way to do it would be to do it manually. So we can say, for example, extension on item where our metadata is article metadata. And then we can say var description is a string, and it returns metadata.description, right? So now we have basically done this manually. So now we can go ahead here and say item.description, and it works as a kind of first class property on directly on the item, which is pretty nice and convenient. But this is not very convenient, right?
You need
like
to write one new wrapper by properties. So yeah, doesn't scale very well.
Doesn't scale very well. It's kind of annoying to have to write this all the time. And yeah, like the little convenience we're getting for this, like we have to pay this. Yeah, so it's lost, right? So can we automate this somehow? Yes, it turns out we can. And the way we can do that is we can make this, annotate this type here with @dynamicMemberLookup. And when we do that, we are essentially telling Swift that this type, we can resolve the members, like the properties on this type dynamically. And at first, when this property was introduced, it was, I think, mainly introduced to enable interoperability with more dynamic languages, such as Python, which enable you to do dynamic member lookup with a string. So we can see here in the error here, it says that dynamic member lookup attribute requires item to have a subscript dynamic member method that accepts either an expressible by string literal or a key path. So it was primarily designed in the beginning to accept a string that lets you then resolve a value from that string. So in a very dynamic way, like now we're definitely talking dynamic programming, right? So it's kind of introducing a little bit of a dynamic feature there into Swift. But now then with KeyPaths, we can take this subscript right here. So we can say subscript dynamic member, and we can give it a key path instead. So we can say, here's a key path, and this I want to be referring to my metadata. So you can use whatever type here you want. And we then want to have a value. And for that, we're going to need to introduce a generic here. So we want the generic type T, and we want to get a dynamic member from metadata and T, and then we want to return T from that. So basically it's telling us that we want Oh, sorry, I have to close that there as well. We want a dynamic member that is a property, a key path into the metadata type that we have. Okay, so what we can return here then is we can return metadata dot or subscript into that with key path
So we
dynamic member.
invoke the key path.
Yeah, so this is how you would retrieve a value from a key path. You do it using this subscripting syntax. So you said metadata, key path, and then dynamic member. And let's see now here, if we try to run here, it says that it requires item to have subscript dynamic member and explicit. Okay, sorry. Yes. Okay. So there we go. Yeah, you need to have also an internal parameter label on your subscript. So that's what was wrong there. Again, this is live, right? This is how you can see it's not a pre-recorded
the
video.
syntax
It's
is
all
hard.
live.
Let's be honest, the syntax
Right.
is hard. When you don't know it, you don't like stumble into it by mistake.
Right. I think that's good also, right? Like this is pretty advanced features, I guess, of the language, right? So you want it to be deliberate. Like you shouldn't implement this by accident. I think
Yes, that makes
that's good.
sense.
Anyway, now we have everything working now. So what we've done here is that we've added a subscript of a dynamic member that accepts a key path into our metadata type, and then we're subscripting it into it using that key path that we were given. Okay, so what does this do then? Like, what does this whole mechanism do? Well, it actually enables us to refer to an metadata property directly on the item, just like we did with our extension before, but automatically and completely type safe. So let's scroll down here, comment this out that we had before. Whoops. Using there we
So
go.
it's commented. It's no longer part of the
No,
code.
it's no
And
longer part of the code, and we can still say item.description, and it still works exactly as before. So I think that's pretty cool.
that's
Like here
impressive.
now, yeah, we can say dot description, ID, metadata, like it all works. And I think that's really cool. Like you can refer to a property that a type really doesn't have, but you can pretend that it has it using KeyPaths.
Exactly. And what's so nice is that everything is type safe. You make a typo writing description, the compiler will catch that error. It's not going to crash at runtime. And
Right.
that's really the killer feature for it.
It's really the killer feature. Maybe we can do a little bit of extra thing here and also make this assignable, because right now, if we try to assign the description here,
You can only
so we
read
say
from it.
we can only read from it. And the reason, so that might seem a little bit confusing at first, because why is that? I mean, we have our, where is it? Here. We have our variable here, which is writable, right? Like, why can't I write a new value to this? It's a var. And it's because our implementation here of the subscript, it's currently, we've only implemented the getter. So there is no way to set this value. So the way to fix this would be, right now we're accepting a key path. So we cannot write to things using just a key path. So we would have to say writable key path instead here. And actually, I think this might not be the best solution, because now we will require all properties here to only use writable key path. So let me just go ahead and copy this and implement a new subscript, which will be writable key path. So I will add an overload here, which we can do because there are different argument types. So
Yeah.
that works. But now we can say, here's the getter, and the getter is just the same as before. But then we can say, here's the setter, and the setter is just assigning the value using the same subscripting syntax. But because we have a writable key path here,
We
we're
can
now
write
able
to
to
it
write
now.
values to it. So that's also enforced by the compiler. And this new value here is also given to us by Swift. So setters always get a new value, which is the new value that is being assigned. So now if we scroll down here and we run the playground again, we can see that if, oh yeah, item needs to be a var too. Sorry.
And we can see the compiler is definitely like tracking things and there is no room for mistake.
There's no room for mistake. Yeah, and that's great, right? So
That's what we want in
get
Swift.
the errors, we can know what we need to fix. So now when we have this var here and we assign new value, it all works. So now we can both read and set values using key paths in a dynamic way that is still completely static.
And you know what? In the chat we have a great remark. So I hope I'm pronouncing what Pratamesh is saying, that you can make even complex key path. For instance, you can key path on a subscript and provide a value. And I would say you can go even further, because here 0 is hard coded, but you can use a function call to get the value for the index. So So you can really make KeyPath expressions that are really non-trivial at all.
Yeah, absolutely. You can really treat them as kind of, if you were using NS predicate in, for example, Objective-C or even in Swift, which lets you filter, and we can look at that use case now if you want, Vincent, but it lets you filter collections, for example, based on like a query. You can kind of use KeyPaths in the same way. Like they might not have all of the power of NS predicates, but you can do a lot of things with them, which is really cool.
I
And it's,
think we
again,
can.
like the difference is that they're completely type safe.
I think we can definitely take a look at it, because I think using KeyPath for predicate syntax, or actually any kind of DSL syntax, it's a great use case.
Okay, great. So let's go back to our user here. Let's scroll up here. So we had our user before, right? We had user and state. And if we wanted to, we could also make this dynamic member lookup-able, and then we could reference state directly. But
Directly.
that would be a repetition of what we already did. So let's leave that for now. But just to point that out, that it would work here as well. But let's say that we wanted to now filter. Let's say we have an array of users and we wanted to filter so we only show the users that are logged in, right? So we would filter on the isLoggedIn property. So if that's true, we want to include the user. If not, we want to not include the user, right? So to do that, let's create an array here. Let's say this is all users. And let's just make a couple of users here. We can make Vincent. And Vincent has a user state of isLoggedIn true and sign up date. You were just signing up right now, Vincent. You're signing up during our live stream.
It's perfect.
All right. Yeah. So yeah, a little indentation here just so we can see it very clearly. And let's then create a second user here, and that will be me. So it'll be John. I can't even spell my own name. And is logged in is false. Okay. So we have one logged in user, Vincent,
And one logged out.
One logged out, which is me, right? Or John. Might be John Appleseed, right? It doesn't have to be me, but
it feels very Apple when you say John Appleseed.
Yeah, for sure. All right. So let's now say that we want to only get our logged in users. We can do that using KeyPaths. So we can say let logged in users equals users, all users, dot filter. And filter here now is interesting because filter accepts a closure. It accepts a closure that goes from a user to a Boolean. So a traditional way of doing this would be to say $0 or user in, whatever you prefer, dot state dot is logged in, right? So this way we can filter away all the users that are not logged in. So only the logged in ones will be included here. But this here is completely fine, of course. But now we can also use KeyPaths here, because it turns out that a KeyPath can also be automatically converted into a closure if the types match. So in our case, if we wanted to use the KeyPath user.state.isLoggedIn, that is, if we run this again one more time, we know, or we saw it before, it's a KeyPath that goes from user to bool. And this closure that we pass to filter also goes from user to bool. So it matches, like the two types matches. And that's really great, because what that enables us to do is comment out this code here. We can remove this for now. And instead say, let logged in users equals all users filter / dot, and now you can see we have state and we have is logged in, and these two things are completely the same. They're functionally equivalent, but if you prefer the syntax, I think it looks much cleaner, and it gives this like lightweight feel to the call, I think.
Yeah, and actually Swift UI relies a lot on this syntax. There are a lot of, for instance, when you create a list, you pass in the KeyPath for the ID, and basically you could pass in a closure also, but you would have curly braces for this closure, then the curly braces for the body of the list. That would be a lot of curly braces on a single line. So I definitely agree that from a readable perspective, it's much nicer, especially in more complex use cases. And personally, the way I feel now is that, so since KeyPath, as you said, they are functionally equivalent to a closure that is a getter closure or a setter closure. If you're designing an API and this API wants a way to get or set a property, you should actually type it to a KeyPath rather than a closure, because here, for instance, in filter, the closure expects to get a Boolean property. But there is nothing stopping you from making a network call in that closure before returning the Boolean if you want. And the filter function has no way to guard against it, even though it would probably work in a very weird way.
Right. And I would argue that for filter, this is the right design, right? Like you want to be able to just write an arbitrary filter that is not just based on a property. So in this case, I think this is all good. And we can decide whether we want to use a closure or a property on a case by case basis. But you bring up a very good point, and that's when you want to enforce that if it's a filter or an ID or a predicate or whatever it is, if you want to enforce that that is always going to refer to a property specifically, then yeah, using a key path there is much better because then you get that guarantee.
Exactly, and you get the guarantee that you are calling a getter and a setter and absolutely nothing else, and you can take it like as something that's given for your code. And
right. Yeah.
maybe something that I would like to talk about. So we said that KeyPath they are very static, and I think it can bring us to one, we could say, limitation of KeyPath is that KeyPath they do not conform to codable. So you have absolutely no way to save a KeyPath and retrieve it at a later time, for instance.
Right, exactly. That's one limitation for sure. And another limitation is you can't currently refer to static properties either. So it's only for instance properties, and it's only for like you can only use it like at runtime. But it's funny when you explain it that way because it's not like runtime. It's evaluated at compile time, but it's like used in memory. Like that's what it's meant for.
Exactly. And someone is talking in the comment about the very special KeyPath, the self KeyPath. And I think it can be useful to say a few words about it because actually it wasn't part of the initial introduction of KeyPath in the language. It came just a little bit after that. And the fact that the people who made the proposal didn't think it would be useful at first, it shows how non-trivial we could say this KeyPath is.
Yeah, absolutely. And maybe we actually should write a little simple Swift UI view to illustrate that, because I think that's when it comes very much in handy when you want to iterate over a type in a for each in Swift UI and you want to specify an ID for that for each iteration and you don't have an identifiable type. So what do you think, Vincent? Should we do that?
Yeah, we can give it a try, definitely.
Okay, cool. So let me go ahead and scroll down to the bottom here. So we continue here. We can import Swift UI here. Here we go. Fun fact, I mean, this maybe is obvious. I don't know if it's obvious or not to people, but you can import things wherever you want in your code. Like, it doesn't have to be at the top. Of course, it's very weird usually to import, like in production code, to import something like in the middle of a file. But when you're doing a playground, why not, right? Like, sometimes I even use import statements like this in a playground as like headers, right? Like, if I like write something with combine first and then with Swift UI, like I import it here. So it's just a little side note.
It's true
But
that I
okay,
didn't know about this.
right, right. So let's do something like this. Let's create an enum here, which we call fruits, and it's going to give us different fruits that we will have in our application. We're building a fruit app here, Vincent, like a big Vincent and John fresh fruit enterprises delivering from France to Poland and vice versa.
It sounds very much like a WWDC demo project.
Right, exactly. Yeah, I'm sure. It's a good thing, right? So the first thing we might have is Apple, of course, here, right? And we can get a little Apple emoji. If my emoji picker, it doesn't work, the emoji picker. All right, let's just type it out as Apple like this then, and let's have also banana. And maybe what's your favorite fruit, Vincent?
I don't know. Maybe we can go with pineapple.
Oh, that's good. That's
I'm
a very
thinking
good
like,
one.
which fruit do I know how to say in English, which limits the list a
Let's
little bit.
let's do kiwi also. Do you like kiwis?
Yeah, and plus they're very easy to translate in English, so that's perfect.
Exactly, it's perfect. So let's make this a string-backed enum like this. So we will just have these raw values here of the fruit names, right, as the raw values of our enum here. And let's also make it conform to case iterable so that we are able to iterate over all these cases here. And now let's say that we want to build a Swift UI list just showing all of these fruits. So one way to do that would be to define a fruit list, which will be a view and it has a body. And the body here is a list and it has a for each. And here we want to iterate over all of our fruit cases. So we're going to say fruit dot all cases. And then we want to open up a closure here, and we want to get a fruit in, and then we want to return a text, which is the fruit dot raw value. Okay.
Perfect.
So currently, this is not going to compile. And the reason it's not going to compile, it's going to say here, referencing the initializer in it with content on for each requires that fruit conforms to identifiable. And our enum does not conform to identifiable. And we could fake that by like conforming to identifiable and returning the raw value as the ID or something. But it would be kind of strange to have a fruit.apple.id, right? Like, I don't know. I don't think that makes a lot of semantic sense in this particular case. So one way to solve this then would be to use KeyPaths. And the way we can do it is we can say ID here. And in this case, we can say \self. And what we're saying here to Swift UI is that the ID of each fruit will be its own value. So if it's an apple, it will have the case apple as its ID, and banana, pineapple, and so on. We could, of course, also say .raw value if we wanted the raw value to be the ID. But in this case, because enums with raw values are hashable, that will work if we just do self like this here. And yeah, now we have our little fruit list here. So yeah, it's we can display it also if we want. We can import playground support, playground page, current, live view, UI hosting controller, root value, root view, fruit list. All right, there we go. Run this. And the signal was interrupted. All right, that's interesting.
Did we make a mistake somewhere? I think since it's a Swift UI view, maybe you can just instantiate it, and you might not even need to use a UI hosting controller actually.
You think that this works?
No, I think just creating a fruit list, a variable that is of type fruit list, and trying to display its content, maybe it could work actually.
Yeah, but how would you display it in a playground without the live view?
You use the button like when you want to display the content of an array, for instance. Maybe I'm getting ahead of myself. We will see. Yes.
Okay.
I think I have used it.
Okay, let's see.
So that's why I'm thinking like.
Oh wow! I learned something new today. This is very cool. I didn't know you could do that. Can you see this also on the live stream? Popover? Oh, you can't see it, right?
Yeah,
because it's not in the same window.
But if you click on the button on the right of the popover, it should. Yeah, perfect.
Yeah. It's very small.
It's very small, but we can see that there is definitely a list.
Oh, we can make it bigger.
Oh, perfect.
Look at that. That's cool. I didn't know this. This is great. This is going to be great for prototyping. I'm very happy I learned this.
And it's much more stable than using the playground support that sometimes it crashes, sometimes it doesn't. This one seems more safer.
Yeah, for sure. Absolutely. Yeah, I was very surprised that it crashed there. But yeah, there we go. We have our fruit list. So yeah, KeyPaths. That's really cool for defining an ID in a for each context like this.
And so this self KeyPath, basically, remember that we've said that KeyPath are functionally equivalent to getter functions. Well, when you write a getter, sometimes you just return the argument. Think when you do a compact map, for instance. Well, when you do the thinking the other way, if you have this getter function that exists, it must have an equivalent in terms of KeyPath, and that's the equivalent. It's the KeyPath that when you invoke it on an instance, you just get back the instance.
Right, exactly. Yeah, it's really useful for cases like this where you want to tell some framework, in this case Swift UI, that you're referring to the self, like the same value that you're dealing with. So yeah, it's really useful.
And so on KeyPath, I think we have covered a good ground, and since we have like something like a short quarter of an hour left, maybe we can talk about another new feature of Swift that is also kind of a niche feature, kind of like dynamicMemberLookup, but this time it relates more to function, and that's the callAsFunction feature.
Oh yeah, that's about as niche as they get, the language features, right? Like that's a very, very niche feature.
Honestly, for me, it was an unexpected one to have, and I get that maybe it is for some kind of interoperability, but for me, what we're going to see, it was very much in my mind associated with C++, and not the kind of thing that I was expecting to be able to do in Swift.
Right. Yeah, that makes sense. So yeah, do you want me to show that then, how we can use this?
Yeah, let's do. And while we do, so there is a very good answer that sometimes trying to use self backs the self KeyPath instead of $0 doesn't work, and it's true. And honestly, I don't have the explanation actually. When I read the proposals, it should work, but it doesn't compile, and I was the first one to be surprised. Maybe it's actually a bug in the Swift compiler.
Okay. All right. Yeah.
But
I
very good
guess like,
remark.
but yeah, in those cases, if it doesn't work for some particular case, you could always use a closure instead.
Indeed.
Yeah. So that's fine. Also, like, I think it's very rare that you want to filter on self. Like,
It's true. It's more
yeah.
for compact map actually that I would see using self a lot, because we do a lot of compact map $0.
Right, because you want to just discard all the nil
Exactly.
values. Yeah. Okay. Yeah, that makes sense. Yeah, that's a shame if it doesn't work like that, but I would assume that's something that will be fixed. So, callAsFunction.
Yes, let's go on it.
Okay, let's do it. All right. So I think this callAsFunction feature, I'm just going to get rid of this here. Uh, one way to explore it is also lets us explore some kind of functional programming concepts, but in a more kind of object-oriented way. And I find that a little bit interesting. Maybe it's not like the most useful in like a production app, but we're just talking about the language here, and it's just fun to explore some language features. Maybe more as a little bit more academic exercise in this particular
Exactly.
case, but it also lets us just learn some more things and visualize some functional programming concepts in a different way, which can also be valuable. So what I'm going to do is I'm going to define a function type here. And I'm going to say that this function type has an input generic type and has an output generic type, like that. So just like any function, you have an input and you can receive an output, right? And this is just a normal struct here, and it's going to have a body. So a similar kind of design to Swift UI in a way, where in
That's
this case,
true.
it's going to be a closure with takes input and produces output, like that. So of course, one way to use this would be to say let, for example, my function here, or actually let's do this. Let's create. Let's go up to our article class from before here, and let's give this one a function here, and let's say that the function here is giving to us whether the title is currently empty, just as an example.
Yeah,
Okay,
let's do this one.
so this will be that is title empty, and it would just be a function that returns a bool, and it would just be title is empty. So not very useful, but it's just an example, right? So now what we can do here is we can go down here and say is empty is function. And here we can give it a body, and we can create an article instance here, like that. And then we can pass article dot is title empty here is as our body. So now we've essentially created a reference to the method on article is title empty, right? And it is a function. And so we can now call this by saying is empty dot body and invoke it like this. We would have to pass the input as well, which is void in this case. And we can now get back true, right? So we're able to call this function by calling its body property, just like this, right? So that's something that we would expect works. And just one thing I want to point out is that when we do this here, we are actually also retaining this article instance,
That's
which
true.
is just a good thing to point out, because in order to be able to call this method, we need this instance, right? So it needs to be retained. But in this case, it's something we actually want in this particular case. But just to kind of keep that in mind if
Yeah,
you will use this technique in the future. All right, so we have the body here, but this here is not very, it doesn't feel very native, right? To call it this way. It feels kind of strange to say is empty body. Like you wouldn't call a function this way. So how
definitely
can we
not.
make this type how can we make this type behave more like a function? Well, we can use the callAsFunction, and that's actually just implemented by implementing a function here called callAsFunction. And we can say here that we accept our input like that, and we produce output.
Perfect.
And we can call the body with our input and return it that way. So it's really just like a little bit of syntactic sugar. And now we can remove this dot body here, and we can still call is empty the exact same way as we did before. And it's pretty wild, right? Like we are calling a struct as if it was a function. So it's right there in the name, callAsFunction. And yeah, it just behaves like a function.
Yeah, as you said, it's just syntactic sugar. Swift has chosen to make us implement this function as call a function, but I remember that other languages, like for instance C++, you do it by overloading the parenthesis operator. So, but yeah,
Right.
just it's just wrapping around. But for instance, maybe I know that. So I've never used this in production, but a use case that I see is that when you have a type where a function is going to be called 90% of the time and the rest of the API is very secondary. Like I'm thinking you have a configurator, you pass it a cell and it configures it.
Mhm.
Maybe making this configure function callable as using callAsFunction, maybe it makes sense in that case.
Right. Or maybe something like analytics, where you always say like analytics.log, right? You could just make that callable as function and or call as function, and then you could just call the logging API directly, like calling the analytics type as if it was a function.
But
So
we are
yeah, there are some use cases to it, but it's yeah. I'm not 100% sure about this feature yet, to be honest. I'm still kind of
honestly,
exploring it, but yeah,
sa-
it's still interesting.
same thing. And one thing that I was a bit like surprised because I thought it would work, but actually, let's say you have an API that expects a function from input to output. If you
Hmm.
try to pass in an object of type function, I would have
Yeah.
expected it to be like bridged because it is callAsFunction, and for me it didn't work, and so like to me it takes back some kind of the interest of the feature because you cannot really like manipulate the object as if it were a function in all situations.
Yeah, that's correct. And I think, it has some implications because closures, they have different kind of memory management and these sorts of things, like they capture their context and they can be escaping and non-escaping and so on. I'm sure there are a lot of complexities there, like that wouldn't let you just pass any arbitrary type that you have defined a call as function method on as, a closure. I'm sure that there would be a lot of changes that would need to happen in the language for that to work.
It makes a lot of sense, yes, and it shows that to me it's a nicety, but I wouldn't expect everyone to find a use case in their app. Definitely not for me.
No, and it's one of those things, like I wouldn't encourage people to go and search for use cases for this, right? Like, don't look through your code base and be like, where can I use call as function? Like it's it's one of those things that once it's good to know about language features, I think. And you will probably never like be an expert in all of Swift language features because there are so many, right? And I'm
And it
learning about
only
new
keeps
language features
increasing
all the
every
time.
year.
Yeah, exactly. But it can be good to know about some of these things, and maybe once you will have a use case for it, it can be a sweet thing to know.
Yeah, and
Um,
there is a very good question before we start wrapping things up is
yeah, sure.
can callAsFunction be overloaded like any other method? Like can we provide several implementation but with different kind of types as the arguments?
Yeah, so one thing we can try is, so right now we still have a pretty awkward calling syntax here where we have to pass in this void parenthesis here because our input is void. And when we have a void closure, normally we don't have to pass. Like that would be strange, right? If we every time we were having a function without any
Yes,
arguments, we would always have to pass two parentheses. Like that would be
that would be
pretty
very
awkward.
weird.
So let's try and say extension here, extension function where input is void. And let's just provide a call as function. I'm just going to type it out here as function without any input and returns output because we know that the input is void. So we can just call our body with parentheses. We can just do it in here, right? So we don't need to always do it at the call side.
And
So
then we
now
can
let's
call the
try,
body normally.
we can remove, we can just do it this way, and now it
Perfect.
still works. So yes, you can definitely overload. This is in fact an overload, and it works. So it's a great way to kind of provide a convenience API here. So you can literally call it as if it was a closure. You cannot pass it as a closure, but you can call it as if it was a closure here, and
And
that all works.
to me, it leads to another remark is that we can do the same thing with dynamicMemberLookup and KeyPath. And this way, for instance, we can build a union type that would take two instances and expose an API that is the union of the API of both types by having one overload with KeyPath of one type and one overload with KeyPath of the other type.
Yeah, absolutely. Yeah, that can totally work as well.
As long as the name doesn't conflict, of course.
Yeah, of course. So one more thing I think we can just show here, if you don't mind, is
Yeah.
so I mentioned earlier that this can be a way to kind of implement functional programming concepts in a more object-oriented way, because even though we are dealing with a struct, not an object, not a class, we're still doing fundamentally like object-oriented programming with types and methods and properties and things like that, which those are not functional programming concepts. If you have a pure functional language, you typically don't have those types of patterns. So one thing that is very common to do in functional programming is partial application, where you are applying a input into a function to get a new function back that does not have any input, but it just applies that that input into the function itself. So one way to illustrate that would be to extend our function here with a apply method that lets us do this in an object-oriented way. So let me write another extension here on my function, and I'm not going to have any where input or something like this here, but I'm just going to say apply, and you can apply an input like this, and we can return a new function that does not have any input, so it's void, and the output will still be output, because we can then take the input here and apply it to our function. So we can return a new function here, and it will get our input in, which will be void.
Yeah.
And then we will return the output by applying this input we were given. So we can say here body
input,
right? And that should give us what we need. Let's see here. We probably just have to do
wants us
.in as well.
Ignore the argument explicitly.
We just have to say also here void output, I think. Yeah, there we go. So yeah, because otherwise it thinks we're dealing with function here means
Oh yes, which is already input and output.
Right. So we need to do this, right, to make sense. Okay, so now we have this. I think we can now remove this. Let's just try. Yeah, that works. Okay, cool. So what we can do now is we can take a function that takes an input and apply this input directly to it, and then we have a new function that just returns the output. So to illustrate that, let's go ahead now, scroll up again here to our article that we had here, and we can say here, for example, is favorited by user. It would be a little bit strange to have the article type maybe know about this, but again, it's a demo, right? We don't have time to write a whole application here, so we're taking.
I mean, the title was not advice on architecture, so it's function and KeyPath. It's fine.
And we can say it's always favorited. Like all the articles are favorites in this application. It's everyone's happy. So now what we can do then is we can take our function that we had here, or we can create a new function. Sorry. So we have already is empty. We can say also here is favorite, and this will be a new function with a body, which will be article dot is favorited by. So we can just say is favorited like that. Now this is if we now run this, we can see that on the right here, we have a function, which is again, this weird lib expression, but it's a user as input and bool as output. So that's what we would expect, right? We give a user as an input to this is favorited method, and we return a bool back. But what then if we wanted to have a version of this that is specific for one user, right? So maybe the user has logged into the application, and we just want to be able to retrieve a favorite for the currently logged in user. So what we can do then is we can take our user. I think we had all users before, right? Yeah, so we just take a little shortcut here so we don't have to define a new one. So we have one user here now. And now we want to apply this to our is favorite. So we can say now specific is favorite. And this is favorite, apply user. And now, if we run this again, we can see now we have a function that takes void and returns bool. So now I can call this one without any argument, thanks to this extension we defined earlier, and it will now return the value for this specific users because we applied it here. So this is something you can do just using closures. You can do it in functional programming languages. They will typically have like either operators or some convenience APIs for application like this. But this is something we can now implement in a kind of more object-oriented way here in Swift because of callAsFunction.
And for people who know about functional programming, we can say that what we've implemented here is some form of currying, right?
It's not currying, because currying is when you are calling a function and getting a new function back and then calling that again. So this is, unless I'm mistaken, these functional programming terms, sometimes I get them confused, but I believe it's called partial application.
Like to me, I use the two words as synonyms, but maybe there is actually a specific difference in the two of them. But yeah, partial application of a function. All right. Well, I think we have definitely covered some good ground. So someone was asking, will the code be available on GitHub? I think we try to put it on a gist or somewhere with a link in the description.
Yeah, sure. I'll send it to you, Vincent, then you can put it in the description.
The replay will be available sometime tomorrow. Just before we end, I think almost everyone is familiar with John's social media and website, but if you're not, I've put the link in the description, and if you've never been there, there's some good stuff. Definitely you want to be there. I'm going to play the little video just to remind you of all the cool things that you can do when you are on my YouTube channel, and you already are on my YouTube channel if you're watching this video. Thank you, John, for being with me and with us this evening. I think we all had a great live coding session.
Yeah, it was super fun. This is also one of the first times I've done this in this format, so it's really fun and maybe something I want to do again. And I also want to recommend everybody that if you enjoyed this with me and Vincent, of course, subscribe to Vincent's channel if you're here. If you haven't been here before, he puts out a lot of great videos, so definitely subscribe. Subscribe, right?
Thank you.
All the things YouTubers are supposed to say. And also, if you enjoyed me and Vincent in particular, we did a podcast episode together a while back, also about keypaths and functions on the Swift by Sundell podcast. So you can find that as well at swiftbysundell.com/podcast.
And I think we've covered a little bit more ground in the episode than in this live. So there might be a bit more information if you're interested.
Yeah, different things, because we didn't talk so much about callAsFunction, I don't think, in the podcast. So, we're using each medium to its advantage here, which is great, right?
I mean, definitely having the ability to show some code, it makes the explanation easier than in the podcast.
Yeah, for sure. Yeah, that's also something that's always challenging on a podcast, is reading out code. So we tend to talk more about the concepts and the patterns and things like that on the podcast. That's what a podcast is good for. Articles and YouTube videos and things, that's where you can actually show the code.
I think that's a great way to conclude this episode. So thank you all for joining us this evening. Thank you for watching, and see you next time.
Yeah, thanks so much, everybody. Thanks, Vincent, for having me, and thanks, everyone, for tuning in.
Goodbye.